Before we factored polynomials, sometimes we did it to solve. Today we're going to simplify rational expressions and fractions. Your favorite F word, fraction. Simplifying radical expressions. Remember the F word, factor, fraction, function. All right, the ratio of two polynomial expressions is a rational expression. It's when you write one on top of the other like a fraction. That's what fraction means, ratio. Okay, multiplying rational expressions, if you take A over B and C over D and you multiply them, you do numerator times numerator, denominator times denominator. When you do division, something happens different. And I don't like how they wrote this, so let me explain what this says. If you're taking A over B and C over D and you're doing A over B divided by C over D, you need to change it to multiplication of the by the reciprocal. That's where they're getting the A times D over B times C. Now, of course, nothing that's in the denominator can be 0. These are just examples of the old stuff you used to do. You don't have these on your paper, correct? So you used to say, all right, 2 times top, top times top, bottom times bottom, and then reduce. Or you did cross reducing or cross canceling. 2 goes into 2 once, 2 goes into 32 16 times. Since 3 and 15 have a common factor of 3, 3 goes into 3 once, 3 goes into 15 5 times, and then you do 1 times 5 and 1 times 16, and you'd have a reduced answer. If you were doing this problem in the past, you would change division to multiply by the reciprocal, and then you could do the same cross-canceling idea. 7 goes into 7 once, into 77 11 times, and 5 goes into 5 once, and into 35 7 times. So this answer would have been 11 7. Let's not spend a bunch of time looking at this example that's filled out for you. And what I want to explain to you is, I am not going to make you do this. Do you want to expand that all out? Probably not, and here's what we'll do. We have learned our exponent rules, so if we have 24, a to the 5th, b to the 2nd in the numerator, the denominator I would simplify by doing everything to the 4th power inside there using the power rule. 2 to the 4th would be 16, a to the 4th, b to the 4th. And now I would expect that you would use your exponent rules and your knowledge of common factors of numbers. You can divide 16 and 24 by 8, so you might do vertical cancellation. 16 divided by 8 is 2, 24 divided by 8 is 3, so we'd have 3 over 2 for the numbers. And then let's use our exponent rules and think, well, I have a to the 5th in the top. Dividing by the same base, I would subtract the exponents, which would give me a to the 1st on the top. I have more b's on the bottom, so I told you guys, instead of subtracting 4 from 2 and getting -2 and then having to move it back down, that if they're both positive, say, where do I have more, and subtract 2 from 4, get b to the 2nd on the bottom. I'm certain that you probably like that better than writing all this out, right? And crossing things out. But this is what it's equivalent to and why those rules work the way that they do. This second example here is simply you factor. If you have a division, you will change to multiplication by the reciprocal and then cancel out any matching factors. Let's get on to doing some together. So to simplify each rational expression, I'm going to tell you that there isn't just one way to do every problem. As long as you end up with the final answer correct, then that's fabulous. I am going to do things the way I think it might be easiest for you to understand my explanation. So I'm going to go ahead and say I see 3 and 6 across from one another. Since this is a product, I'm going to go ahead and cancel out and do 3 divided by 3 is 1, and 6 divided by 3 is 2. Now, I feel like when we start doing too much canceling and writing on these things that we start to get lost and we might mess things up. So I'm going to go ahead and multiply my numerators. That'd be mf to the 3rd, 1mf to the 3rd. And 2f times 2 would be 4f. I will be posting to Google Classroom. You can then say, well, that's f to the 1st on the bottom. If I subtract the exponents, I'll have mf to the 2nd over 4. That'll be the end of that one. Number 2, if we look at this -1 exponent out here, I'd like to get it, I'd like to get rid of that. I'd like to change this so that I don't have to deal with that. What would we need to do? Flip this over. That would take care of that and make it a positive one. So let's do that right off the bat. So we got 24g to the third over 5f to the second times 10. Now, at the same time, please, since TF are in the parentheses with 3 on the outside, that means we have to apply the power to both the G and the F. So I'm going to write G to the third, F to the third while I flip it over, and then just 8 G to the fifth, F in the denominator. Okay, now I'm going to start looking at what I can cross cancel. I'm going to work with 5 and 10. 5 goes into 5 once, into 10 twice. And then I'm going to cross reduce or cross cancel. 8 goes into 8 once and into 24 3 times. Just so we don't get all confused, I'm going to go ahead and multiply my top times top, numerator times numerator, if you will. 3 times 2 would be 6. G to the third times G to the third would be G to the sixth. Add the exponents, and then I'd have an F to the third. If you want to do more canceling where you were before, that's okay with me. Just make sure you're ending up with the same thing. In the denominator, 1 times 1, of course, 1. F to the second times F would be F to the third. And I have a G to the fifth. I just wrote them under each other. You don't have to. Okay, now I need to reduce. I have a 6. I have G to the sixth on top, G to the fifth on the bottom. 6 minus 5 would be 1, so I'd have G to the first on top. And then the F to the thirds would just cancel out. So the answer is 6G. Okay. Number 3, I have a division. What I need to do right away is change the division to multiply by the reciprocal. So I'm going to rewrite the problem. That is 80 y to the fourth over 49 z to the fifth v to the seventh. Change the division to multiply and flip over the second fraction. 14 z to the 12th v to the fifth on top. 25 y to the fifth on the bottom. Okay, now I'm going to start doing some cross canceling. 49 and 14 have a common factor of 7. So 49 divided by 7 would be 7. 14 divided by 7 would be 2. I don't know why I started with those instead of 80 and 25. But 80 and 25 have a common factor of 5. 25 divided by 5 is 5. 80 divided by 5 is 16. I don't want to get all crazy here yet, so I'm going to go ahead and multiply my numerators. 16 times 2, I've got 32. I've got a y to the fourth, z to the 12th, and a v to the fifth. In the denominator, 7 times 5 is 35. I've got a z to the fifth, a v to the seventh, and a y to the fifth. And I'm not worried about putting those in alphabetical order any particular time, except maybe at the end. 32 35ths is not going anywhere. That's not reducible. I have v to the fourth on the top, v to the fifth on the bottom. Excuse me, I said the wrong letter. Don't know why. Y to the fourth, y to the fifth. So if I subtract 4 from 5, I'll have y to the first on the bottom. And you can write y to the first if you want, or leave off the 1. We've got z to the 12th in the numerator and z to the 5th in the denominator. If I subtract 5 from 12, I'll have z to the 7th on top. And then the v's, I should have probably taken care of them first, but whatever. V to the 7th on the bottom, v to the 5th on the top. I'm going to subtract 5 from 7 and get v to the 2nd on the bottom. And that's done. Did I do it right? What do you mean? Yeah, that's fine. Because V comes before Y in the alphabet. So that's what the book would say. Yes. I just didn't want to get that nitpicky right now. But yes, alphabetical order is the best way to write your variables. All right, number 4, 5 and 6. Now we're going into factoring. Okay, so we're going to need to factor a monomial factor out if possible. Always look for that first. Then factor your trinomials. So I got to divide by 3, so I'm going to write 3 times x minus 2 over factor the denominator, x minus 3 times x minus 2. The x minus 2's can cancel out. They have to match identically. The whole term, if you will, right? It has to be the same thing in the parentheses. That's 3 over x minus 3. You cannot divide those 3's. These are married. They're stuck together, okay? It's not a product. You cannot cancel or divide by 3 top and bottom here and write 1s in their places. You can't do that. These are married. So I'm saying married because it's just weird and you might remember it. Don't separate them. Separate them. All right, we got y plus 5 times y minus 3 for the factorization of that numerator. And the denominator will have y plus 4 times y minus 3. Maybe you've noticed there are variables in the denominators. That should raise a red flag. But since we're not solving, I'm not worrying about the fact that the denominators cannot have certain values. Y minus 3 cancel out. All I got left is y plus 5 over y plus 4. End of that one. Number 6, 4 goes into 4 once, 4 goes into 12 3 times. And then I'm going to go, okay, 7 over 15. I got 7x to the second over 15x to the fourth. And then I'll go ahead and say, well, I got more x's on the bottom, so this is going to be 7 over 15x squared. Subtract 2 from 4. Okay. All right, so everybody's flipping their page. Here we go. The next section. We got a lot of factoring to do here. Difference of perfect squares factors to x plus 5 times x minus 5. The denominator factors to 4 minus x times 4 plus x, or vice versa. It doesn't matter what order. Times second fraction. The numerator has a monomial factor of x. Factor out an x. X times x minus 4. The denominator, 2 factors out times x plus 5. Okay. In the top of the first fraction and the bottom of the second fraction, we can cancel out the x plus 5. Now, what else can I do? But we got a little issue here. Can I cancel the x minus 4 with the 4 minus x? I can, but I got to do something. Okay, so when you have exact opposites, guys, if you had negative 5 divided by 5, what are you going to get? Negative 1. Those are opposites. So when you divide them, you get negative 1. Now, another way for me to explain that is to tell you that I can change this to negative 1 times x minus 4. Wouldn't that change the sign of both of them? So I factored out that negative 1. So now it matches this one. Right now I can go and cross cancel x minus 4, but don't forget there's a negative 1 there still. All right, so now let's see. Anything else canceling out? No. All right, so I've got that negative 1. I've got x minus 5 on top and x. So let's just start writing it. X times x minus 5 all over negative 1 times 2 would be negative 2. And then I'd have, I'm going to rewrite that 4 plus x to x plus 4. You don't have to, but your book probably would. Now, most of the time in your text or in a standardized test, they will not leave the negative sign in the bottom. They would apply it to the top. So that you would know that and recognize it, I'm just going to move the minus sign up top and then leave the rest alone. And some books or some tests might actually even distribute these out. But I'm not going to, I just assume you leave them factored, okay? All right, let's try another. Y squared plus 6y plus 9 is a perfect square trinomial. Factors y plus 3 times y plus 3. I am going to write both of them instead of writing it quantity squared because of what's coming. All right, so now I'm going to factor out a 2 from the denominator. That's going to be 2 times y squared minus 9. Oh, that y squared minus 9 is factorable. Well, let's hold off a second, okay, and see what we got up here. I got to factor out a 3 from the numerator of the second fraction, which would give me 3 times the quantity y squared minus 9. Oh, great. And the denominator, factor out a 6, 6 times y plus 3. Now it's looking like, well, why bother factoring those guys? Because they're going to cancel out. Y squared minus 9 with y squared minus 9. A y plus 3 with a y plus 3. Oh, 3 and 6. I can divide 3 by 3 and get 1, by 6 by 3 and get 2. You can vertically cancel as well. Okay, and then my numerator's just got a y plus 3 left. Times 1. Don't need to show that. All over 2 times 2, which is 4. Anybody need this still? Okay. Number 9. Factor out 3 in the numerator. 3 times y minus 4. Factor out the 2 in the denominator. 2 times y plus 2. Change the divide to multiply. And flip the fraction. Okay, and I'm going to factor out a 4 at the same time. 4 times y plus 2 on top, and on the bottom 6 times y minus 4. Start looking for things to cancel. Y minus 4s, y plus 2s. Oh my goodness. I think there's even more. 3 goes into 3 once, and 3 goes into 6 twice. Well, I have 4 on the top and 2 times 2, which is 4 on the bottom, so this whole thing is equal to 1. Okay. Scott. I can. I could have. I just felt like it was getting a little too weird. I could have done all that, but it was just getting like too much crossing. I feel like if I do things like that, you're losing track of what's going on. So just don't do that to yourself to where you can end up screwing up something, you know. So sometimes I just think it's better if you just rewrite things and simplify it one more time. Okay. So yeah, you were right. I could have. So if you did, then and you got it down to 1, you're all good. This one would be n minus 2 times n minus 3 factored, and the bottom is n cubed. Change your divide to multiply and flip. 4n squared on top. The denominator factors to n plus 5 times n minus 2. All right, so I got to whack out those n minus 2's. The n squared will cancel with it'll be n to the first instead because I subtract 2. And that's about all I can do. So I've got n minus 3 over n times n plus 5. Did I do everything right? Oh, I forgot about my 4. It's still there. No one got rid of him. So 4 in parentheses times n minus 3. That happens. Try not to forget anybody. I think I just have a couple more. Oh, actually, the fun part. Complex fractions. Fraction over a fraction. Well, guess what? This bar right here, the one that's between a fraction over a fraction, means divide. So if that just means divide, then what you end up doing, you can rewrite it as a division problem if you want, but I usually will go right from this step to this step. where I rewrite the numerator, flip over the denominator, change divide to multiply. Okay, then factor and reduce. Let's do it. Okay, so I'm gonna factor and flip. Okay, remember this means divide. Okay, so I'm gonna start with the numerator factored out. 3x will be a common factor of both terms. So I'm gonna have 3x times x minus 3 over x minus 2. I'm gonna change the divide to multiply. So I changed it to multiply. And I'm flipping the bottom fraction over. So 4 times x minus 2 will be my top. X squared minus 9 is the bottom, but I'm going to factor that to x minus or plus 3 times x minus 3. It doesn't matter what order you wrote it. All right, now I'm going to do my cross canceling. I hope I didn't do too much at once. If you want me to show it a step in between there, I certainly can. Does anybody want me to show the step before this? I'll be happy to do it. If you think you need me to, I will. Otherwise, if we're good, I'm just going to multiply across now. 3x times 4 would be 12x, and on the bottom, x plus 3. Can't separate these guys. They're married. I thought I better bring that up again. Do not try to divide the 3 and the 12 here. You can't just start crossing stuff out. You can't cancel the x's either. Okay, x plus 3 have to stay together. Forgot to say that again. All right, x plus 5 times x minus 3. Factor the numerator. 2 factors out times x minus 4. Change the the middle division thing to a multiply, and then flip over that second one. X plus 4 times x minus 4. And then I'll factor x squared plus x minus 12 would be x plus 4, x minus 3. Okay, I'll start canceling stuff. Yeah. Oh, vertical cancellation. All I have left is an x plus 5 over 2. Your challenge, and I made it into a worksheet. Although odds in your book that you probably have stuffed under your bed at home are in the back of the book. Or if it's in your locker buried at the bottom. There aren't many odds here, but I printed it out for you and made it into a worksheet. So you've got it. I would begin working on that right now. You got quite a bit of work time today.